Hello everyone, my name is Danielle Gonzalez. I'm a PhD student at Rochester Institute of Technology, and I'm going to talk about how developers unit test token authentication implementations. So do user authentication is typically a form where they have to put in their username or password. Sometimes this can look a bit different, such as if the credentials are provided in multiple steps, or if the user is allowed to authenticate with credentials from another application, such as logging in with Google on Stack Overflow. Authentication is highly customizable. There's several mechanisms, types, and protocols that can be used, and a single application can use more than one. And while developers are encouraged to use security frameworks such as Shiro, Spring Security, or Passport, the APIs for these are themselves complex. So how do developers make sure that they've implemented these correctly? Well, in a developer's toolkit, their primary testing resource would be unit testing. So how do developers unit test authentication? And another important consideration here is what guidance is available to help developers to do this. Unfortunately, there's only one respected security testing resource that advocates using unit testing, and that is the OWASP Web Security Testing Guide. And they advocate that it's a good practice and there's many benefits to it, but when they actually go to list their test cases, they're all written from a black box context. So that would require a running instance of the system. So for example, one of the scenarios they give is testing for weak password policy. And the suggested test case just asks, is the user prevented from using his or her other account information in the password? And given just this test case, someone who wants to write a unit test may not be sure if it's actually even unit testable. And further, it takes a lot more cognitive effort from the developer to determine how the test case would be designed. Unit tests have a very specific format where they have key elements such as the setup, the action or the manipulation of the code under test, and some sort of expected outcome. And it's not immediately clear from this phrasing of the test case how that design looks like. So that's what we're trying to figure out in our work. We used a grounded theory-based deductive analysis to actually characterize the authentication scenarios that developers commonly test. So what is unit testable? We curated this into a taxonomy of 53 unique test cases, which we represent visually and as a test guide. We also enumerated test smells that we found throughout our data set that seem to be common to these unit tests. We sought feedback from developers, 2 of which actually authored tests in our data set to make sure that our findings were accurate and our test guide was actually helpful. We made this test guide publicly available, and we also released a replication package, which includes all of the data used in this study. We had to scope the work to make a grounded theory analysis feasible because it is primarily manual work. So starting with the domain of web applications, we look at Java projects that write their tests with JUnit and use the Spring Security framework. And further, we've scoped this to token authentication. We feel that these restrictions still represent a generalizable sample of authentication unit tests because these are popular and highly used languages and frameworks. To collect our data, we started by cloning 100,000 randomly selected Java repositories. We did the standard filtering, but also removed any project that didn't have JUnit tests because we wanted to parse these test files and look at what they were importing. Specifically, we wanted to identify test files that imported Spring Security authentication packages. And to go a step further, we parsed the ASTs of every single test method to isolate methods that used these package objects. In total, we had 481 unit test methods from 53 open source projects. So we manually analyzed these 481 test methods with our grounded theory approach. This is an overview of this approach. We started with open coding and memoing, moved on to selective coding, sorted our memos, and conducted theoretical coding to transfer this large set of JUnit test methods into a test guide and an analysis of test smells. So to break this down, to start with open coding and memoing, we wanted to look for themes within the tests, and we wanted to summarize and take notes on the test methods. And considering the key elements of a unit test are found within each test, we wanted to use the Gherkin format to make our memos and essentially summarize every single test case. So for example, we have a test method here, testing JWT filter invalid token. It's the name of the test. We also have the setup and all of the declarations. So we turn this into the following Gherkin memo. The scenario is the name of the test. The given keyword shows the preconditions. The when keyword shows the action. And the then keyword shows the expected outcome. And all of those ands are supplementary steps and manipulations that happened in this rather complex test. And these memos also included the codes, which are the key concepts that we identified within the test. Through all the different coding phases, these were merged, separated, etc., iteratively to most accurately represent the themes that we were seeing across the entire data set. Moving on, we translated these memos into natural language test cases, and we, as I mentioned, iteratively updated our codes. And eventually we ended up with a testing guide and a test smell analysis. So the testing guide is based on the taxonomy that we developed through theoretical coding. So this starts with 5 features. These are high-level categories for related test cases. So for example, refresh token. We had 17 unique scenarios, which are combinations of preconditions and manipulations of the code under test. We had 40 conditions, which are influential states or events, such as a specific parameter value that was passed to a method call. We also had 30 unique expected outcomes, which is the desired state of the subject under test at the end of the test. So in total, we have 53 unique unit test cases for token authentication. So there are 53 unique combinations of each level of this hierarchy. And we visualize this using flow diagrams. So this is the flow diagram for the token authentication feature. And I'm going to go through one of these scenarios in detail to see the test cases for the token pass to authenticator scenario. There are 5 conditions. When you're passing the token to the authenticator, it could be valid, empty, expired, missing one or more details, or one or more details could be incorrect. And so the expected outcome will be based on the condition. If the token is valid, it will proceed, but for all of the cases, it should fail. So if you follow the flow diagram from left to right, parsing through each box individually, you end up with a unique test case. And we have similar flow diagrams for the other 4 features: token manipulation, refresh token, login, and logout. For time, I won't go in depth into all of these different features and scenarios, but these flow diagrams are included as part of the publicly available testing guide. And they're also in the paper, which I encourage you to read. We also found for our test smell analysis 6 known unit test smells that occurred repeatedly in the dataset: obscure test, conditional test logic, test code duplication, assertion roulette, excessive mocking, and issues in error handling. So going back to our example tests, we actually can see an instance of assertion roulette here. So there are 2 assertions here, and neither of them actually have an assertion message. So if it fails, how can you tell which assertion actually called failure? This is extra effort required on the part of the developer. We also identified 2 new unit test smells that we did not find in prior literature. The first being testing the framework, in this case, the authentication framework. One test case in our dataset actually validated the correct behavior of a cryptographic hash whose implementation was provided by the Spring framework. Now, this was not an integration test. It was simply giving this implementation a value and checking the output. And because this is implemented by a third-party library and not the developer themselves, it shouldn't be the developer's job to actually write this test. So it's basically writing an unnecessary test. And the second is testing the mopping framework. There were multiple occurrences where test cases were essentially doing so much mocking that they weren't actually testing their own implementation. Now, to gain feedback on our taxonomy, our testing guide, and our flow diagrams, we started with interviews with 2 authors of unit tests in our dataset. And we did this through semi-structured interviews, which were guided by the following questions: the background of our interviewees, Both of them had a lot of experience developing in Java. The first had 20 years developing in Java and 5 years using Spring Security. And the second author had 18 years of Java development and unit testing, but they had worked on very little authentication code. So this was essentially both ends of the authentication experience spectrum. And so as far as their involvement in writing and testing authentication in the project, the first developer wrote most of the project's initial authentication unit tests. These unit tests are part of the project itself, so any other project that uses it, it becomes part of their test suite. And these tests are still in use today, even though the developer works on other things now. The second developer does not consider himself an expert in authentication. Essentially, he just was the person who had to write the tests, even though he did not know very much about authentication. So this leads to the next question, which is how did you determine which test cases to write? Developer 1 started by just making sure they had enough coverage, and then they reiterated and went back and added more tests that weren't caught by coverage and things that were a little more complex, such as the token providers. Developer 2 only cared about coverage. That was the only thing driving him. He did not have any authentication-based or security perspective when writing and designing his test cases. So we asked them if this unit testing guide for authentication would be helpful for them. And developer 1 said that it is an improvement because there's no other guide like this today. And specifying which tests are unit testable is very useful. The second developer said that even though in the beginning, because they only cared about coverage, the guide would not be helpful, when they actually move forward to caring about authentication, then he would have found this guide useful. We also talked to 2 external reviewers who did not contribute to the dataset, and we sent them a copy of the test guide, which at the time did not include the flow diagrams, and asked a comment on the format, the contents, and the overall usefulness, as well as any other comments they might have. And these 2 developers also had significant experience, especially developer 1, and they had both implemented authentication in the past. Considering format, both agreed that it was not difficult to understand. Reviewer 1 suggested that the test cases be presented as sort of a flow, and so we took this feedback and incorporated those flow diagrams into the test guide, and there were some minor grammar changes that were requested, which we acknowledged in the next revision. Both reviewers seemed to think that we covered most of the contents. There was 1 missing test case suggested that we did add into the final version. And both practitioners also think that overall the test guide was very useful. In fact, the first reviewer quantified it as 70% of it being useful to them. So we took their feedback in mind and we updated our testing guide, and we also publicly released our dataset as a replication package. We encourage you to check it out, look at the data. It includes all of the test files analyzed, organized by the project they came from, as well as the memos from both of the reviewers. Also, we encourage you to try out the test guide. Take a look at it. This is just a sample for the refresh token feature, but it includes the flow diagram. They're organized by scenario. Descriptions and rationales for writing the tests are provided, and all the test cases are written in natural language. And the language used is general so that it should be applicable even if Spring Security is not being used. If you have further questions or comments, I encourage you to join the Q&A session for MSR, or you can contact me directly at the following email address or my Twitter handle.